Okay, as a continuation for last review session today, we're going to be looking more of a focus on how to use the whole statistics. So we're going to be using the anorexia dataset. Um, I don't know exactly where the experiment begins. I couldn't find it, and honestly, I couldn't be asked to find it. But for all intents and purposes, as long as you get it with this exercise, I think you should be clear. So the first thing we need to do is, of course, define our data frame and open our Excel dot read rad Excel. You do backslash, and you just copy path. You don't have to put it anywhere special. I usually just drag and drop my files. It works. There's no need to do import your Google Drive or anything else. Just drag and drop. Come on. It's quick, easy, and simple. So as you can see, first let's read our instructions. Um, so they're telling you a 98% confidence interval, so we can already assume our alpha values of 0.02. And people gaining weight. So here's something you have to consider. Exclude the control group. So you want to calculate a confidence interval for the percentage of people with a positive change in weight. So you already know by it telling you percentage of people, what can we assume there? If it's telling you percentage of people means proportions of people. So we can already start making our confidence interval checklist that we did last time, where we have our p-hat, our standard error, SE. By the way, since this is going to be using stats, we don't need to necessarily make, stats models. We don't need to make this checklist, but it's just so you guys are used to us making a checklist and like know what composes a confidence interval. We need our C star. C star. There we go. So yeah, as you can see, we already know where. Oh God, this is. How do I delete that? Clear all my drawings. Okay, so we already know that the first thing we need to do is exclude our control group 2, because it's telling us exclude control group 2. So essentially what we're going to do is just completely create a new database. So let's do df.df, df. And within this, we want to exclude our group. So so for Python, so we know that our control group is group 2, right? So we do equals. So this operand is basically not equal to. So that's like essentially saying like this. So oh God, that is a horrible drawing. So you're essentially telling it to, anyways, is essentially the exclamation mark and the equal sign. That's what you're telling Python to do. So you're telling it that it is not equal to 2. So if we reprint data frame, let's see if we don't get any errors. Perfect. So we still have group 2. Give me 1 second. Okay, so essentially what I did wrong was this was supposed to be DFA, and this is supposed to be DFA because this is the data frame we want to be working on. So if we run this here, DFA is not, forgot to do this and run it, and there we should have everything sorted. So it is telling us you want to see what people, I know what's going on. Sorry, that was another mistake I made. There we go. So there we are, actually excluded. I'm sorry, this I'm recording this at 9:46 a.m. and the coffee has not hit. Um, so I'm a bit slow. So apologies for that, but if you exclude my mistakes, this is the process you have to follow. So here we essentially split our data frame, telling it, hey, from data frame A, um, exclude every value that is 2 within the category group. So you're telling it within data frame A from category group, if it's not 2, add it to the main data frame. So here, the next part you want to add is to find the difference. So we already have a column called different weight, but let's add a little just complexity to this problem so you guys can start seeing how this works. So we're gonna create diff. This will be df, and we're gonna do post weight minus df dot pre-weight. Is that the right? Yeah, print. Um, so we're essentially telling it here, we're doing what this column is doing essentially. Is you can see if you subtract pre-weight from post-weight, you're gonna get the difference, and that's what diff weight does. But in order to make this a little more similar to the problems we're encountering, let's create our own df diff. So as you can see, this does the exact same thing. You can see it's the exact same values. I just wanted to show you guys where it came from. So I don't know why it's giving me all of this. It's telling you a value is trying to copy whatever. The code ran. Don't worry about any of this. Hopefully it doesn't give us problems, and if it does, I'll just run it over diff weight. So the next thing this is telling us is you want to see what people gain weight. So here we're going to use one of the quintessential operands that you may encounter. So you're going to add a new value to your data frame. So we're going to label this gained. Let's put this did person gain weight. This is a terrible way to label a variable, but it's just so you guys have it completely clear what I'm going to do here. So we're going to use our dear MP-where. What does MP-where do? And I'm just going to get my post-it from my window because I've had this post-it for like a month now. So the NP-where, you're essentially glorifying an if statement. So I'm gonna write it like this: if condition is satisfied, then do this, apply this, and else, if not, then apply the other thing. So in this case, we're gonna use 1 and 0. Just gonna get this out of the way. That I don't know if this works with pandas because I think pandas can read this. It doesn't matter. Anyways, so that's what MP-where does. If the first condition is satisfied, then it applies the first thing. And if it's not satisfied, then you apply. Is that the right way to spell apply? I think that is the right way. It doesn't really. So we're here we're seeing whether or not a person gained weight. So how do we see if a person gained or did not gain weight? So we look at the difference. If the difference is positive, then that means they gain weight. So we're gonna do df, and we're gonna use diff, the variable we already established up here. If it is greater than 0, we're gonna give it a 1. So that we're telling it our first condition for the MP-where. So we're telling it if the first condition is satisfied, you apply a 1 to this new data frame. And if it is not, you're gonna put a 0. So let's label this a little different. This is gonna make it a bit harder down the line, but so you guys are clear. Let's do this. Now, because what could we put for ineffective? That's the right way to spell it, I think. My language skills are in terrible display here. Make a lot of spelling mistakes. So essentially, what you're telling it is if the person gained weight, apply gain, and if they did not, you apply the other thing, which is in this case ineffective because we're looking at treatments. So in order to stop getting this message, I'm just going to change it to TIF WT. It's going to do the exact same thing, but it's not going to give us, it's going to give us the annoying message for some reason. Let's try, what if I put this semicolon? That should get rid of it. No, it does not. Okay, doesn't matter. So the next thing we have to do is actually create a data frame, or not a data frame, a confidence interval. So, yeah, going back to this, I'm actually gonna, and I had to go and copy and paste the formula because I don't have it memorized. This is 1 and 0. So, I returned it to 1 and 0 because it's a lot easier for this. I just wanted to show you guys what would exactly happen. So in this case, it would gain weight and then it would be ineffective, but let's go back to 1 and 0. It is because it is a lot easier. So for this, we're going to use SMP. SMP, we're defining it somewhere here. Do I have it defined? No, wait, let me just get that in it real quick. Okay, so I did not have that downloaded because we frankly don't use SMP that much. We usually just do SMW. But still, it is good to have it there. But that goes to show you how little we actually use SMP, but you still need to know it. So here we're gonna define our alpha 0.02. Because since our confidence interval is 98%, our error for alpha, I think that's type 1 error, whatever, is 0.02, which is 1 minus 0.98. So the first thing we're going to do is count. So we're going to do data frame, and then we're going to put our did person gain weight, which by the way, I want to show you guys how this looks like actually before we proceed. Oh, it's going to give me a lot of values. Let's just do df. So as you can see, here the person, this in ID 103, the person did not gain weight, as you can see in the both differences. So did person gain weight? 0. But here the person did gain weight, so it is 1. So we're going to put this in, I'm going to copy this from here because it is a long question mark. Then knobs is a very funny way to label something, but it is a number of observations. So you can usually just do n goes df, and then did person. I have it copied, I think. Yeah, I do. So did person gain weight dot count. That is pandas documentation. So n, and there you have it. And then alpha equals alpha. So you just print lower upper. And if everything goes correctly, it did not. What happened? Give me 1 second. Okay, so I figured it out. I forgot to just add the sum here. That was what was wrong, and that what was going on, but that I cannot speak. But yeah, so now our thing is working, as you can see here. And yeah, so now all we have to do is print our lower and our upper. And there we go. That is perfect. So yeah, that is SMP. That's stats something proportions. Stats dot models dot proportions. We rarely use it. I copied all of these from like our final like stats thing. Like our final stats collab sheet, and SMP was not there, so that goes to show you how little we use it. It is still something important to use. Um, and yeah, that's the first exercise we're going to be looking at. This one is with proportions, so if we would have wanted to do it, we would have followed this same process using like p hat and whatnot. It's just now we did it with Python. So I'm gonna pause. I'm gonna copy the instructions from the second one. Okay, so after I accidentally deleted labs 3, now we're back to where we were. We are now using the extra datasets.xlsx. So yeah, so you import consider the salary of the top 40. What is the average salary of the 40 CEOs? So we're gonna find the 95% confidence interval for the mean salary of CEOs. So the first thing we have to do is look at which documentation we're gonna be using. So last time we did SMP.proportions, now we're doing SMW. So as I told you guys, something we use a lot is res. It means results. So we're gonna do smw.tsstats. This gives you, I think, because I don't know exactly what each variable does. I just know why it does. I just know what it does. But we're still gonna try to get every like descriptive statistic of the salary, so mean, standard deviation, and whatnot. We're gonna do the following. So we're gonna do DF, and within DF, we're gonna choose the category salary as millions. So then, and this is the beauty of SMW and just generally doing stats on Python. We're gonna do question 1. So you're gonna do lower, upper equals is, oh, I forget the formula. Give me 1 second. So we're gonna use, and sorry, I was just copying it because I can't be asked to memorize it. We're gonna use res.tconfident of means. So first we need to define our alpha, something I forgot from my own checklist. So it is telling us a 95% confidence interval. That means an alpha 0.05. So that is our alpha. We now have our results. So we have our lower, our upper. And why we're doing t-confident and not z-confident is from the fact that we're manipulating means and not proportions. So here we do lower, upper, and we're done. So we can already start formulating conclusions from literally 3 lines of code. So if you remember for the raw stats, we did all this thing, calculated everything. This one does it for us, so that's perfect. So here we would print, we are 95% confident that the population salary in millions of CEOs is between 52.739 or 740, you round up, and 72.274 million. So that's question 1 done. Easy as that. Remember, res t-confident, you have to use a t-confidence interval because a z-confident interval would not take into account the degrees of freedom needed. So the next question is, is average salary the same across different industries? So for this question, I know for a fact because I remember the teacher saying this. Um, we're gonna just directly look at it here because it is way too complex for what we're gonna have to do. We're not gonna need a for loop or like a for iterand. So as you can see, the teacher just gave us like something very complex. But for question number 3, and we're not gonna look at this right now. So you can see it here. Does average salary depend on the university degree? So here she is probably or our teacher is a she for my class. I'm pretty sure we could do a NOVA here. I am not 100% confident, but I'm pretty sure we would do a NOVA here because if you can see, it's telling you bachelor's, law, MBA, master's, none, and PhD. So we're comparing means of 1, 2, 3, 4, 5, 6 categories. So once we review ANOVA, I'm gonna come back to this one and see if we can get it. I'm not 100% confident because we need to use the for and whatnot. But yeah, that's just, I wanted to give you guys a look at how to use the SMW to do 95% confidence interval of one sample. So yeah, that's the recording. And that's it for block 3. There's not much else you need to know. So yeah.